Welcome to SPC Tutorials. In today's video, we're going to talk about addition and subtraction of vectors. But in actual sense, what we are going to do will be more than that. But one thing I must assure you of, for this video, we are not going to talk about the direction of a vector. We'll only talk about the magnitude, how you add vectors, how you multiply them by scalars, and projection, unit vectors, and so on. But we'll not talk about the direction of a vector in this video. In our next video, we'll be talking about the directions of vectors. Now, follow me carefully. I'm very sensitive. But before I start, please do not forget, like and subscribe to our YouTube channel. Follow us on all our social media handles. Now, let's kick off. Let's say you have a vector that moved from the origin point and moved to this place, x, moved to this place, and the vector then moved upward to this place, y. Now, in writing this as a vector, this is where the position of where that let's say a body moves. This is the position it went to. So he either went through this side, then here, or went through this side, then to this side. But this is the final destination. In representing it as a vector, this is what we take as the vector here. This is what we take as the vector. So we can actually call it the position vector of this body with respect to the origin. When you talk about position vector, you are talking about a body at a certain position, but with respect to a certain place, which we call the origin. We can be talking about the position vector of another body here, but not with respect to this, but with respect to this. So it all depends on how the question comes in. But now let's continue. Now, what is the magnitude of this vector? What is the size of this vector? How long is this vector? Mind you, this is angle 90 degrees. This is angle 90 degrees. So instead of us tracing from here to here, we were able to break this straight length into two parts, which is the horizontal part and the vertical part. Now, after breaking it into these two parts, we now remember that from Pythagoras' theorem that the sum of the squares of the adjacent sides of a right angle triangle is equal to the square of the hypotenuse. So this will now lead us to Pythagoras' theorem, which says that the square of this is equals to the square of x squared, because you move from here to x, so this is x squared plus y squared. So arrow. But the magnitude of the vector is actually not written like this. When you see this, it is in vector form, and it is usually written as this. This is to tell you that I is the horizontal and J is the vertical. That this guy moved x times, x meter or x feet, or whichever word they are talking about is, towards the I direction, and move y towards the j direction. This is what this means. But the size of the vectors is now what we want to calculate by using Pythagoras' theorem. Now the size or the magnitude of the vector is written in this form. You can see this absolute value sign. So the magnitude will be square root of x squared plus y squared. That would be the magnitude of this vector. So you can be asked, what's the magnitude of 3i plus 4j? As easy as that. Square root of 3 square plus 4 square, which is square root of 25, which is 5. As easy as that. Now when looking for magnitude of the vector, the sign does not matter. If there was a minus sign here, the minus sign will still go out when you square it. So the minus sign does not really count. There are cases where it counts. Is when you are looking for the direction of the vector. So this is how you get the magnitude of a vector. This is the vector. This is the magnitude. This is the vector. This is the magnitude. So now let's talk about 3D vectors. Let's go over to 3D vectors so you know how these things were gotten. Now let's say you have something like this. Let me put it this way. Let's say this is your x, this is your y, and this is your z. I want to trace a body that moves to the x direction to this point. Let me call this x distance. The body moved to x distance first, then the body moved to this direction. It's like a flat surface that is like this. The flat surface has this dimension. You can move, this is the origin in the flat surface. This is the origin. You can move towards this side. You can move towards this side. This will be positive, or this will be positive and negative. Positive and negative. Then you can decide to move upward or downward. So if we take up as our positive, this top will become our y-axis, positive y. Below my hand will be my negative y. Then if I move towards this direction, any of this direction, this becomes my positive x, this becomes my negative x. Then we have one more direction that we have not moved to. Because this is a flat surface, it is difficult sometimes to explain 3D in a flat surface. So the last direction is this direction. So you can see that this is the positive z and this is the negative z, but this is my origin. So now, let's assume we move to the positive x distance. Then you now move to the positive z, this direction. So you first of all moved here, then you moved here to this point. Before you now started moving upward or downward, then you now decided to move upward, 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 upward. So this is actually where you finally got to. But when representing this in a vector, from the origin, you draw it like this, arrow. So we can say this vector arrow is xi plus yj plus zk, because you move towards the x-axis to this point, then from the x-axis you moved upward. Look at where you moved to, but it's a flat surface, that's why it's difficult. That's why you can see I drew it this way first, so that you understand the movement. So you moved towards the x-axis, towards this direction, then you moved upwards from y to this point, then you now moved back to this direction. So this is what it means. Now, how do we get the magnitude of this vector? Now, if I isolate this part and leave just this part, if I isolate that part and leave just this part, you will observe something here, that this is a vector already. This is x and this is y. This is a vector. And the magnitude of this vector, since you move xi plus yj or zk, the magnitude of this vector in our first example will be square root of x squared plus z squared. So it means that from here to here is square root of x squared plus z squared. So we have gotten that part. Now we are looking for another angle 90 degrees. Now this is still on a flat surface. Don't be confused. You are on a flat surface. It's just like this. You are on a flat surface. You are on a flat surface. We have gotten the magnitude of this vector here. Then we want to now get from here to here. So we have gotten the magnitude here. Now from this point you moved upward. So on the flat surface you were like this. You were of this length, x squared plus z squared. Then you now moved upward, y distance. You now moved upward. This is what that triangle is meaning. Then you have something like this. Then you have arrow. So how do we now get the magnitude here? Square here equal to square of this, square of this. So our arrow square will be, which is now the magnitude of the vector, will be square root of x squared plus z squared, all square plus y square. So this square will cancel this. So we are left with arrow square to be x squared plus y squared plus z squared. Now if I find the square root of both sides, I will have this. So it means that if it is a 3D vector, our magnitude of the vector will be x squared plus y squared plus z squared, all square root. So I'm just showing you how it was gotten. Now let's move to our question 1. We are to add the vectors, we are to add the vectors a plus b plus c. Now, in adding vectors, we add common axes. Common axes. Now, the i's will go together, the j's will go together, and the k will go together. I would like to explain why. Let's say you have a ball, and a boy drags this ball towards this direction. Another boy comes and drags this ball towards this direction. You are using 8 Newton to drag it towards this direction, and a boy is using 3 Newton to drag the ball towards this direction. Now, what do you think the resultant force will be like? This guy is moving with a higher force. So because this guy is moving with a higher force, it will have to, first of all, that means the ball will have to move towards this direction. But one thing you must notice is that the ball will no longer be moving towards this direction with 8 Newton. The reason is that out of this 8 Newton, someone is removing 3 Newton from it. Someone is removing 3 Newton from it. So the strength at which this ball will be moving will no longer be 8 Newton because 3 Newton is already out of it. It will now be 5 Newton. So working with only these axes, the resultant of this will be 5 Newton. That is how vectors also work. Now, instead of, let's say the ball was moved towards this direction instead, 5 Newton. 5 Newton. And someone is dragging it here. Definitely this ball will be moving around this region because something is dragging it towards this side and something is dragging it towards this side. So it means that this ball will finally not just move towards this side or this side. It will move around this region. So as it is moving around this region, it is difficult for you to know the exact magnitude it will use because it's not just a straight line. What you do, you break these forces into several components. That is why we now have the horizontal and vertical component. Now this force can be broken down into 2 other forces, which is this 3 Newton, and I'm assuming like this 4 Newton. So it means that this 5 Newton can be broken down into this. So it means that someone is dragging this ball towards this direction with 3 Newton, and someone is dragging it towards this direction with 4 newtons, so that the resultant will be this. How did we know that the resultant is this? Pythagoras theorem says the resultant should be 5 Newton, square of this plus square of this, then you find the square root. So we have been able to break that down 5 Newton into 2 other vectors so that we can easily analyze these vectors. Now, if we want to now check for the horizontal part, where would the force go towards? Now, the force 3 Newton is towards this side, 5 Newton is towards this side. Now, if you drag a ball towards this side with a force, and you drag the same ball towards this side with the same force, the ball will not move because the 2 forces are balanced. So it means that the resultant of these 2 forces is 0. So it means that this ball will not move towards this direction. It will only move 4 Newton upward. So we have been able to prove that if you have something like this, that it is possible that this will move, that the final resultant force will be 4 Newton. But I am not saying that when you see this, you should choose this. I have not put a direction here. I'm giving an instance. So with this, we will now be able to understand some other questions that will come into place here. Now let's move to the questions now. So we are adding the ones that are the same direction. Now we have A plus B plus C. What's our A? Our A is since we are adding A plus B plus C, we'll just have A plus B plus C will be equal to, what's our A? 2i plus 3j. What's our B? Minus 3i plus 4j plus 5k. And what's our C? Plus minus 2i minus j minus 6k. So add all the i's. 2i minus 3i is minus I. Minus I plus 2i is plus I. So we have 1i, or just write it as I. Then add all the j's. 3j plus 4j is 7j. Then subtract 1 is 6j. So we have plus 6j. Then there's no k here, so it's 0k plus 5k, which is 5k. Then subtract 6k from it. That should be minus k. So that was just the answer for question 1. For question 2, you are multiplying with a scalar. You are multiplying with a scalar. So what you do is multiply each of them with that scalar. So first of all, what will be 2a? About 2a, multiply this by 2, multiply this by 2. You're going to have 4i plus 6j. What will be our 3c? So since we are doing 2a minus 3c, our 3c will become 2 times 2, which is 4i, 2 times minus 1, which is minus 2j, then times 2 here, which is minus 12k. Oh, we are multiplying by 3, so this is 3 times 2, that's 6. 3 times this, that's 3. So this should be 18. But what did they ask? They asked for this. Don't mind you, this means magnitude, so we are not looking for a vector. Our answer should be a single number. So what will be that? This minus this, so we have 4i plus 6i minus 3 minus bracket 6i minus 3j minus 18k. Then we are looking for the magnitude of everything. So 4i minus 6i, that's minus 2i. 6, this is j. 6j minus 3j, this becomes plus, so we have plus 9j. Then 0k minus this is plus 18k. Mind you, this is not what we are looking for. We are looking for the magnitude of the resultant. So the magnitude of this will be the square root. I told you, ignore the minus sign. 2 square plus 9 square plus 18 square. So you can use your calculator to do that. We have 2 square plus 9 square plus 18 square. Then you find square root of that. You get 20.22. So the magnitude is 20.22. Don't forget it. So let's move to question C. Question C. For question C, we are looking for the resultant of a plus b minus 3c, then dividing it with the resultant of the magnitude of this. We have gotten this already, so we don't have any stress there. So let's do that. So instead of wasting much of our time, a plus b minus 3c will be what is our a? 2i plus 3j, then plus our b plus minus 3i plus 4j plus 5k. Then we have minus 3c. What's our c? 2i minus j minus 6k. Then everything divided by 20.22. So let's do the math. 2i minus 3i, that's minus I. Then we have minus 3 times 2, that's minus 6. Then we have minus 7i. So this is minus 7i. Then we have 3j plus 7j, that's plus 4j, that's 7j. Then times plus minus 3 times minus 1, that's plus 3. So we have plus 3. So this will give us plus 10j. Then lastly, there's 0k here, so no need. We have 5k plus minus 3 times 6k, that's 5k plus 18k. That should be plus 23k. Everything divided by 20.22. So you can leave your answers like this, but you can also separate it and do this. Minus 7i divided by 20.22 plus 10j over 20.22 plus 23k over 20.22. So this is also a vector. If the question had put this, we would have been doing square root of this square plus this square plus this square. That would have been our answer. So for the fourth question in this video, we have a unit vector in the direction of 3a minus 2a minus 3c. A unit vector in this direction. Now, what did we say unit vector is? We said unit vector, the magnitude of a unit vector is 1. Now, we have a vector, for example, that is not a unit vector. Let's say we have 3 and we have 4. it is moving towards this direction. But we want a unit vector that we also move towards this direction. How do we do that? First of all, we know that the magnitude of this vector is 5, but we are looking for a unit vector x, xi plus yj that will move towards this direction. Now, if I find the magnitude of this vector, I will get 5. Now, if I divide each of these vectors, each of these sides by this magnitude, I will have 4, 3i, 3j, 3i plus 4j all over 5. If I divide it by the magnitude of the vector. So if I separate it back, now when I find the magnitude of this vector, I will get 1. Because the square of this plus the square of this will give me the square of 5, which is 25. So it is with that knowledge we now know a possible unit vector that we can use that will be in the same direction of this. Now how do we get our 2a minus 3c? As usual, multiply this by 2. 2a, 2 times 2, that's 4. Then minus 3 times 2, that's 6. So we have minus 2i, just as we had it in that last video, in that last example. We have 2 times this, which is 6, minus 3c. 6 minus 3, that's plus 9. So we have plus 9j. Then lastly, we have minus 3 times this plus 18k. So this is our 2a minus 3c. But how do we now get the unit vector that will be in this direction? As easy as that. The unit vector that will be in the direction of a certain vector b is giving us the vector b all over the magnitude of the vector. Just take note of it, that the unit vector that will be in the direction of this vector b is giving us the vector b divided by its magnitude. So the unit vector that will be of this direction will be this vector all over its magnitude, which is 20.22. So this is minus 2i plus 9j plus 18k all over 20.22, 20.22, 20.22. So this is the unit vector. Now if you decide to find the magnitude of this vector, you will end up getting 1. Now this next question is a projection of b on this. A projection of b on this. Let's assume that a force moved towards this side 3 and move towards this side 4. This is the force, but the distance is moving is 3 meter and 4 meter. But now, when we are getting the vector, we are not getting the vector in terms of this force. We are getting the vector in terms of the distance it is moving. So we have to express this force, we express this vector in terms of this force. So this is the aim of this question. So the projection of this force on this vector arrow is what they are actually asking you. The projection of b on this. First of all, you have to find the unit vector of this that is moving towards the direction of this. Then you now multiply it with b. Now we have gotten that unit vector as this. Then we have to multiply it with our b. So first of all, what's the magnitude of b? You have to know the magnitude of b. Now the magnitude of b is 3 squared plus 4 squared plus 5 squared. The square root of that answer. So now you have gotten the magnitude of b, then you use it to multiply the unit vector that is in this direction, which is this. That will be your answer. So that's all for this video. In our next video, we are going to talk more on vectors, addition, diagrammatic addition of vectors and subtraction. Then we'll talk about the direction cosines of vectors. Then in our next video after that one, we'll now start talking about dot product and cross product, giving you reasons why this is dot product, how it was gotten. Please do not forget to subscribe to our YouTube channel and share our videos. Follow us on all our social media handles. Thanks for watching.
Learning online haven't been more fun. Exquisite Online Tutorials is a household name when it comes to academic excellence in online tutoring of 100 level students to 100 level students and college entrance examination candidates. With the power of artificial intelligence and human studies. Exquisite online tutorials have been able to interact with the intelligence of students worldwide, making the good ones better and even the better ones best. Just like Science Bob, Exquisite Tutorials has a great faculty of erudite tutors that inject knowledge, whether science or business management, to the cerebrum of her students. QTME lectures and other college entrance examination lectures are going on as well. Do you still need a physical tutor? No. Exquisite Tutorials got you. Please subscribe to our YouTube channel and follow us on Twitter and Facebook.